Okay, so how'd the homework assignment go? Ish? Not too bad? Okay, so this is really following the exact same logic as we had done previously, but now we're building this into using Blockly to depict this. So now what we were supposed to do was we were supposed to convert a decimal number into a binary number. Correct? So we're going to first write the algorithm generically today, and then we're going to talk about methods a little bit. Methods would kind of connect to our idea of behaviors. And, well, here, let me actually just give a definition of a method here real quick. So up to this point, we've kind of talked about the way human beings solve problems is through memory, asking questions, and repetition. Well, we might throw a fourth thing in there. That's more of a convenience tool, and that's this idea of a method. A method is a reusable chunk of code that we can write once and call over and over again on different inputs. Okay, so from our perspective in here, for this homework assignment, let's say, I asked you to basically hard code in a number. The number 11, the number 28, whatever it is, and then go through and convert that to its binary equivalent. Well, it would be beneficial for us to write that little machine that converts any integer into its binary equivalent so that we don't have to go and change that value every single time and hard code it in. That makes sense? So no different than us having these convenience tools at home. Somebody created the toaster. So every single time you want to make toast, you don't build a brand new toaster. You buy a toaster. Now this is a guy you could always just put toast in or bread in and hit the button and it makes toast, right? Okay, so the idea of methods we're going to introduce here through Blockly as well. Okay, so let's go and solve this. All right, so for starters, we're going to need to give ourselves a variable. We need some memory, correct? So we're going to go ahead and create a variable here. We're going to rename it, and let's just call it val. And val is going to be the number that we want to convert from decimal into binary. Sound good? All right, so we're going to go ahead and let's, we'll pick our favorite starting number. So let's make this the number 27. Sound good? Okay, so just as a quick reminder, we'll come out over here. If I want to turn 27 from decimal to binary, I'm going to divide 27 by 2 over and over again and record the remainder, right? So 27 divided by 2 is what? 13, remainder 1. 13 divided by 2 is 6, remainder 1. 6 divided by 2 is 3, remainder 0. 3 divided by 2 is 1, remainder 1. 1 divided by 2 is 0, remainder 1. And we know we're done when we get to the 0. So our final answer is read from the bottom. I always pick these ones that are the same forwards and backwards. So we're going to actually change this to a 26, which makes this guy a 0, correct? All right. So this would be, we read from the bottom up, 11010. Okay. I changed it just so the number wouldn't read the same forwards and backwards. So we actually be able to test our solution and see that it's working correctly. Seems like I have a bad habit of that, just picking numbers that always have the same forwards and backwards. All right, so we read the answer from bottom up. All right, so this is what we're trying to solve here in our code. Now, we're going to need another variable. We're going to have something we're going to remember our solution in. Okay, so we have the 26. We're going to have this guy stored. But now we need to build up our answer inside of something else. So I'll change this to 26. All right, then I'm going to go ahead and give us another variable, another guy here. And we're going to rename this, and let's just call this guy answer. Okay, and we're going to start answer off as the empty string containing nothing. And then we're going to build onto that. We're going to append values onto that. Okay, So now, how long do we want to keep doing something? Well, we want to keep whittling 26 down over and over and over again until it finally gets to a 0. Each time through, we need to record the remainder inside of our answer. And we need to record, and then we need to reduce val. Okay? So we need to do something repetitively. We do this through loops. All right, so we're going to look at our loops. So we ask how many times we want to do it. Well, we can do it so many times, or we can do it as long as while something is true, or we can do another counting problem. So this repeats it 10 times. This would also repeat 10 times. So this one, oh, sorry, didn't mean to do that. This one and this one kind of do the same thing. This goes through every single element in a list, and we're going to be looking at that later today. This gets us out of a loop, continues through a loop, things like that. Okay, but we really want to keep going as long as some condition is true. So we're going to repeat something. And we have a couple of options. So we can repeat while something is true or until something is true. Okay, so really in our case here, we can do either. We can say while it's greater than 0 or until it equals 0. Make sense? Kind of do either one of those. So let's just do the while because I think that's going to be more consistent with our modern programming languages, the solution it'll produce for us. And we'll look at that solution in Python afterwards. So we're going to do while, and we want to do this based on some logic. While what is true? So we're going to take this, and we're going to say while our variable val is still greater than 0. Okay, that is to say, we haven't whittled it down to 0 yet. We need to keep dividing it by 2. Make sense? And each time through, what are we doing? We're going to be adding something onto our answer, and then we're going to be whittling it down. So we need to divide by 2 first, then we need to get the remainder. Or, I'm sorry, we'll get the remainder first and then we'll divide by 2. So we're going to do some math stuff, but actually we want to add this to our text. So we have a variable called answer here that we're going to be appending something to. And what are we going to append to this? We're going to append some value in here. All right, so what does this let us do? I don't think that's going to do it. Got to find the right tool for giving us, unless it lets us do this. Can we take this part off and append on a number? Let us do that. Let's say maybe. So we'll give that a shot. So we're going to append some text. What are we going to append? We're going to append the result. Hopefully this has our modulus in it. Doesn't, so it's going to be a function. We're going to append the result of let's try this. Nope, not in there. I know we saw it last time.
It's where it says blank is even. If you're looking for
oh, this guy? Oh, this has module, modulo.
Well, it has no visible by. In last class you said we'd look at that for
Okay, this would work, but there is a dedicated remainder. Oh, here it is. This is what I'm looking for. That other one would have worked. I'm just trying to keep it consistent with how we did it in Game Salad. So we're going to take the remainder of val. It's under variables. When we divide it by 2. Okay, now this will not actually change val. This just takes whatever val currently is, divides it by 2, and appends the remainder of that onto our answer. Okay, and I'm hoping we don't have to turn this guy into a string. I hope this just works. I think it probably will. Okay. The reason why I questioned it is because append, this function here, came with a string, but I had to disconnect it, so it came like this, and then I just deleted this part off of it. I think this will probably work. It may actually give us an interesting thing, maybe a difference between JavaScript and Python, but we'll see. Okay, so each time through this loop, I'm going to append onto my answer the remainder of these. This is going to end up building answer backwards, but that's okay. We're going to take that for right now. Okay, then I need to update val. So after I've gotten the remainder, I need to go ahead and I need to set val equal to val divided by 2. Okay, and hopefully this does integer division. We'll see. So we're having to learn the Blockly way of doing this. This is kind of like with Game Salad when we had to learn the Game Salad, the matrix that Game Salad worked in, the rules. Okay, and I think did we see last time that there was actually a difference in output between JavaScript and Python for a couple of examples? Did we show that last time? Okay, so kind of depending on the target language, because remember, Blockly itself is not a programming language. It's a tool that then allows other languages to be generated from it. And sometimes, depending on the nature of those languages, you might get different results from the same blocks. All right, we'll look at that. We'll see if we stumble on that. All right, so each time through this loop, we'll append something onto answer, and then we're going to set val equal to whatever it used to be divided by 2. We'll spin back up, and then we'll ask the question, is val still greater than 0? That make sense? Okay. As soon as val is equal to 0, what do we need to do? That's when we're down here. The very last time through, we recorded the remainder, divided, and now val is 0. Do we now have our answer? In this case backwards, but we have our answer. Okay, so what do we want to do in the end? We're just going to print our variable answer. Okay, so in this case we have val starts off as 26, answer starts off as nothing, so we've defined 2 variables, 2 attributes, okay, and these are their starting points. We're going to keep looping as long as val is greater than 0. That's something we did with a timer in Game Salad, or for some of you use loops. Then we appended something onto answer. What did we append? The remainder of this and this. And then we're going to set val equal to val divided by 2 when all this is said and done, as soon as this loop finally ends. So this stuff right here blocks. It does not allow us to get here until it's done. So in the end, we're going to print out the current value of answer. Very nice. Okay, so what does that tell us? That tells us that this division here does not do integer division. It's
the val divided by 2.
Yeah, this guy. So it's giving us fractional numbers rather than integer division. So we need, and let me just run this again real quick. So you see we're getting all sorts of 0.5, things like that, although I would have thought, so it looks like remainder is also.
Well, the remainder is fine. It's the one below it.
Yeah.
But I'm ultimately printing out answer.
Yeah.
So the only thing we're appending on to.
Well, that gets messed up because of the value, because the value becomes a decimal, and then when you put it back in, when it's divided by 2, that becomes a decimal as well.
Okay, so remainder is returning a decimal value in the event that.
Because the second one gets
Okay,
messed up.
I got it. So this guy, we need to do something to this value to make sure it's an integer. So let's look at math functions here. I see we have a round, but round might not be what we want, but let's just see if we have a. Will round down always work?
Yeah.
Yeah, does we do that?
Yeah.
I think when we did it in Game Salad, didn't I come up with an interesting
-1, I'm pretty sure.
something with what the remainder was? So we want to take this, round it down, We put it in here like that.
Mm-hmm.
And now we get a number like this, which is actually backwards. Okay, so that's actually something interesting we got out of that, that when I say val divided by 2, it does not automatically do integer division. It does math division, what we talk about in real life. So that means that this guy right here is not necessarily an integer. It's just a number, which actually plays into these languages that Blockly exports to. JavaScript and Python, as well as Dart, are all loosely typed languages. Remember when we talked about the different types of programming languages? Loosely typed languages are languages that don't require us to define what kind of value a variable is built to hold. So notice here in JavaScript, we have our 2 variables, val and answer. Both of these are just generic variables. Similarly, in Python, val and answer are also just generic variables. They don't specify in these languages what kind of value they're built to hold. If we were doing this in a language like Java, we would have said int val is equal to 26. From that point forward, anytime we used val and we divided it, it would treat it as integer division. So whole number, it would truncate because it was known to be an int, not anything else. All right. So we learned something about Blockly there. But now our string is being built backwards. How do I fix this?
You change a variable.
Do what?
Change a variable. You can do it. I don't know what it's called. I think it's in the variables.
Okay.
Set item to.
Are we changing answer?
Yeah.
Okay. So try your way. So let's go down here. So I'm going to change answer to what?
And then you put in that where you have the math signs, those 2 things.
This?
No, that's the remainder one.
Oh, this guy?
Yeah.
Okay.
And then if you put val, or not val, you make a new variable for a 1 or a 0 from.
Now tell me at the high level what you're trying to accomplish, rather than in Blockly.
You're gonna have to do an else, because if it's a 1, then you add on 1. If it's a 0, then you add on.
Okay. Well, but this is going to give me that. This is going to give me that 1 or 0 right here.
Well, right, but then you need to add it on, and it's adding it on backwards. So if you have it this way, then you're gonna put like where it says val, that set answer to. Then you're gonna have that where it says val right there.
Yeah.
You put in the 1 or the 0 from the answer that you get, and then you put answer where the 2 is.
Okay. So what you're saying is instead of appending something to answer
Right.
directly, we're going to set answer to something.
Exactly.
Okay, so you want to come in here, do you want to set answer, we'll throw it up here for right now. We're going to set answer to something else. And what are we going to set it to? We're going to set it to the remainder of this, followed by what?
Answer.
Followed by answer? Well, how do I get answer in here?
You can use the standard addition function.
Okay, so now actually this would be kind of an interesting thing. I don't think, we'll do it this way for right now, but I don't think this would work in every single language. And this might be the example we talked about last time. So we're going to set answer equal to the remainder of val divided by 2 plus answer. In many modern languages, the plus sign, when dealing with a string on one of the sides, is treated as the concatenation operator. The same thing as the dot operator. Okay, and we talked about that last class, right? All right, so this would technically work. It'll definitely work in JavaScript. Does it work in Python? I don't think it works in Python. Let's check. So this would, and then we can get rid of this for right now. We'll run this. So there's our answer, our correct answer. But let's jump into Python here and let me copy this code. Go out to the terminal. Okay, we'll run this, and it does not like the plus sign. So Python doesn't like using the plus sign for concatenation, for gluing stuff together. JavaScript does. Java uses the plus sign. C# uses the plus sign. A lot of modern languages do, but Python doesn't. So is this an acceptable solution? Sure, it's an acceptable solution because the way we're running this is by hitting the play button here, and it's running the JavaScript version of this, which is right. But let's see if we can give ourselves a more universal solution, which means that we can't directly use this plus sign here like this. We literally need to build our string backwards. So how would I do that? What are some other options I could do? So I'm definitely going to be building a string. So I'm going to say we're going to set answer to something. So we're adding on to answer. And what do we want to add on to answer? Well, we want to add on to answer the remainder of what answer, the remainder of our math, followed by whatever answer currently is. Somehow. We need to glue these things together in that order, right? All right, so let's look at its functions. We're going to use that in a second here. Let's see, how does create... So create text by joining together any number of items. So let's try this. And we're going to join together this guy and this guy. And that's going to be what we're going to set answer to. I think that would likely work in all of our languages. So we're going to set answer to some new text created by taking the remainder and attaching it to answer. Let's make sure it gives us the same result here. It does. Now let's see the Python version. All right, so notice what it changed here. It's still using that plus sign for concatenation, but notice that what it's doing is it's giving us the string version of val mod 2. So it's getting us the remainder, but then it's converting it into a string so that the plus sign here is treated as a string. JavaScript, it didn't actually have to get, well, it actually did convert it to the string version in here too, even though we saw just a second ago it didn't have to. Because the plus sign in JavaScript does allow us to glue a number to a string. As long as one of the sides is a string, the whole thing will work. All right, so I should be able to now copy this Python. Go out here to my terminal. Okay, that's very interesting. So our remainder, so this is our 1, this is our 0, this is our 1. One, 1, 0, 1, 0. Yeah, it just formatted it really funny. So we're starting val is 26, answer is nothing. As long as val is greater than 0, we're going to set answer equal to the string version of val mod 2 concatenated with answer. It's almost like converting a string to a string was a problem. And then we're saying val is equal to math.floor. Let's try something here real quick. doesn't like cat. The question is why did it give us this format in the first place? So this should give val divided by 2, and we can come in here and we can print out val each time if we want. And see val whittling down. So val start off as 13, 6, 3, 1. So it really looks like the issue is that it's always giving us a decimal point. So it's getting the right answer. This is 1.0, 1.0, 0.0, 1.0, and then 0. So we really need to make it an integer then for it to work in Python correctly. We're getting the right answer. Let's look at the blocks here. Do we have a math? Maybe round, or rounding it down. Why doesn't that make it a, shouldn't round down make it a number? Okay, well, we can pull it off this way then. Now, I didn't expect you to do this for your homework. This is more just an interesting thing. As long as yours worked with the JavaScript version, that's all that was required, as long as it works in here. So we have another function here that allows you to get a particular value from a variable. So what we're going to do is we're going to take the we want to create text with this guy. I think that'll do it. Oh, that won't work in there. I want to turn this into text. Then I want to get the very first element from that. All right, so then what we're going to do is we're going to say set temp. We're going to create a variable called temp. And temp is going to be equal to, I'm going to say create text. And let's see what this guy lets us do. Okay, that's fine. And I'm going to do the remainder of this as one thing of text. And I doubt it's going to let me leave this blank. So then I'll make the second thing of text just the empty string. So this will make the text that is whatever the remainder is, followed by a string. So this will give us that string of that. And that's temp. And this will get us the first letter of temp. So we're going to go ahead and get set temp equal to just the string version of our remainder. And then we're going to concatenate only the first letter from that with whatever our answer is. And then we can round down when we do the math each time. This should give us the same output here. And now I think in Python, this should give us the correct output. Yeah, there's 11010. All right, so I mean, not that important for us in here, but more of an instructive thing where not all languages are created equally. And this really comes down to something we talked about very early in this course, where there's a whole bunch of different types of programming languages, but they all fall into a certain container. Okay, and then something we've talked about more recently is this idea of a cross-platform tool, that when you use a cross-platform tool like Blockly, this tool has to export to multiple languages, and it has to hit the lowest common denominator of all these languages. So very quickly, we can see that doing something that was fairly easy to do for the JavaScript version didn't work out so well in the Python version, because these languages, while very similar languages, that they're both high-level, interpreted, general purpose, loosely typed, we can say object-oriented programming languages, that's fair enough. They're both the same classification of language, but because each of them has a couple of different rules associated with some of the operators, outputting to these two guys do not necessarily give you exactly equivalent results. Okay, so something we talked about in here is if you're going to use a cross-platform tool, probably the example I gave, something like using AppCelerator or something like that to produce both an iPhone and an Android application. You got to consider that even though you're building it the AppCelerator way, and in this case we're building it the Blockly way, what it produces may not necessarily be completely identical results. There might be a quirk in the Android side that doesn't exist in the iPhone side because it's trying to make it work from a single source to both. That makes sense? So we can imagine if we were able to do something this easy, this is a fairly simple little function in Blockly, and already discover some problems between JavaScript and Python in this, that Blockly might not be a great tool for writing cross-platform stuff. That's not its purpose. The purpose of it is to learn programming visually. But we could already see some of those inconsistencies. Kind of make sense? Okay. So for us, let's stick with the JavaScript. Well, actually, we've already written it. It's not that big of a deal then. So what I'm going to do is we're going to learn how to take this and put it into a function. So we're going to build a function. So function is a synonym for methods. Okay? Now, this really has some historical significance. A method, the name method, was created with object-oriented programming languages. Before that, when we had procedural languages, we had functions and procedures. Functions returned a value. Procedures did not return a value. Other than that, they were identical. They both took some number of parameters, including 0, so took some inputs, and then did something with those inputs to solve a problem. Functions ultimately returned something after solving the problem. Procedures did not return something. They either printed something or just did the work and was done. It didn't actually return a value to be used someplace else. All right. Before these two guys, we had probably something called subroutines. So in even older languages, we had subroutines. So these guys, I would say, are all synonyms for each other. All right. But in Blockly, we have this thing called a function. So we go into functions. And when we create a function, the function is going to be to do something. So that's going to give us our name. So what I'm going to do is I'm going to go ahead and just drag this guy out here for right now. And we're going to call this guy convert, well, let's call it decimal to binary. Okay, that's what this guy is. And we're going to say he actually requires an input. Okay, and we're going to call, actually, just so it all works, let's call it val, which matches what we wrote up here. Okay, so this guy's going to take in a single input to work. So input called val. Now, what we're going to do is we're going to take all this code and we're going to shove it into our function. Okay, now we no longer have to define val in there. Val is coming in as a parameter, as an input. So whoever calls this function is going to pass this val, and all the rest of our logic in here are going to do things in terms of val. That make sense? So we've defined this function. Now, we'll go ahead and call this function. So let me just put this up near the top a little bit. All right, so we're going to call this function and we're going to pass it our 26. Now notice these guys aren't linked to each other. A function definition stands on its own. And if we look at the code of this, we notice we have a function up here. Here's our function. This is the logic of our program. So if I run this, if I take this guy out, and all I've done is defined a function, this program does nothing. This is an untapped resource as of right now. So if I run this, nothing happens. Because all I have is a defined function that never gets called. Similarly, in Python, I have a defined function that never gets called. But I'll go ahead and put that code back in. So now I'm actually calling that function. And we see that we get the same answer we got before. I can now call this function a second time. And let's pass it 212. So there's our first answer. There's our second answer. Okay, so that's our function being called a second time. So I'm calling our function multiple times, passing at different inputs each time. That makes sense? Now we have a reusable chunk of code. Okay, questions about that? Now, what if we wanted to go the other direction? So I have my decimal to binary here. And we can leave this function up here if we want. But what if I want to write a function that converts a binary number back to decimal? That is, I have my number 11010, this guy. To decimal. So we want to get a 26 out of this. We want to ultimately produce a 26. How do we do that? This deals with our places, correct? This is the ones place. This is the twos place. This is the fours, eights, 16s, right? Each time through we take this value and multiply it by the place. Add it to a running total. Make sense? So in this particular case, we're going to have a 0 times 1 for the ones place plus 1. Let's just put it in parentheses. So a 0 times the ones place plus a 1 times the twos place plus a 0 times the fours place plus a 1 times the eights place plus a 1 times the 16s place. So this is 0 plus 2 plus 0 plus 8 plus 16, which is 26. Make sense how that worked? Okay, so now we want to create a function that does this in Blockly. Okay, and for this one, we'll just make sure it works in JavaScript. We won't do this extra jazz. All right, so I'll actually just to clear us some space, I'll get rid of this guy. All right, so we're going to create a function. And we're going to call this function binaryToDecimal. Okay? And this guy's going to take a string as a parameter. So it's going to need to take in a binary representation of a number. So here's my input. And we're going to call this guy, I'll just call it bin for binary. Okay? And our job is to produce the decimal equivalent. And for right now, we're going to print it. Notice that, that we can't do it with that, but can we do it with... Notice we can make a version of this that actually returns an answer. This guy right here, we can have it return a value as well. Okay, for right now, we'll just do a print like we did before. Okay, so it's going to take in a binary number. We always start with the ones place. At the far right, we start with the ones place. Okay, so this is the ones place, the ones place, twos place, fours, eights, 16s. So it's going to be in our best interest to walk this string from the end to the beginning. All right? Now, it just so happens that in Blockly, we have a loop that goes between two positions. So this loop right here starts at a one number and goes to another number and changes each time by this amount. So in this case right here, we start at 1, we go to 10, incrementing by 1 each time. So this is 1, then 2, then 3, then 4, then 5, all the way up to 10. Okay, so what we're going to do to start off with is we're going to see if we can just display our string backwards. Show our string backwards, proving that we're walking it from the end towards the beginning. Okay? So we're going to go ahead and go in here. And this variable I, nice little throwaway variable, but we're just going to use that to count through our string. We need to start at the last legal position in our string. And if we look at text, we see that text has a length. So I'm going to replace this guy. We're going to get the, we're going to put it, just drag these out of here for now. We actually want to start at the length of bin and go all the way to 0. Now the reality is that while I'm not positive at this point, in fact we can probably just, well, we'll just test it from this. If this works like modern languages, which it should because it's outputting to modern languages, so the JavaScript, a string is going to be 0 indexed, which means the very first element of a string will be at position 0. The last element in that string will be at its length minus 1. So a string with 5 characters in it will have legal positions of 0, 1, 2, 3, and 4. All right? So we're actually going to need to start at the length of this guy minus 1. That's what we want I to start at. We want it to go all the way to 0, stepping by a -1 each time. So if the string had, in this case, 5 characters in it, we're going to start at position 4, then go to 3, then go to 2, then go to 1, then go to 0. Make sense? Okay. So that's what we're going to do in here. Now we're going to go into a text thing here. And we're going to say we want to get the letter at a specific place in bin. And the place we want to get this letter from is we have an option for a letter number. The letter number we're interested in is our variable named I. Give me the letter at position 4. Give me the letter at position 3. Give me the letter at position 2, so on and so forth. Okay? And what do we want to do each time? We're going to go ahead and we're going to print that letter. So the text we're working with is our binary number, and each time through this loop, we want to print the letter that lives at position I in bin. Okay? And then we'll go ahead and call binaryToDecimal. We're going to pass it our string, and our string was what? 11010. So that's our string. So we expect there to be 5 print statements. It's going to print a 0, then a 1, then a 0, then a 1, then a 1, if this is written correctly. Okay, so start off with a 1, then a 0, then a 1, then a 1. Oh, okay, so that's actually interesting. So then we don't need this. We can start off at the length and go to 1, going by -1 each time. There's our 0, there's our 1, there's our 0, there's our 1, there's our 1. And then we're done. That's actually quite interesting that it works that way, because I guarantee you in these two languages here, let's just look at Python real quick. Oh, they implement it in a different way. Yeah, it's actually very interesting. This is not how I would have written this code in Python. This is about 3 times longer than it would have taken to write it normally in Python. But this is the Blockly way of doing it. And for us, we don't care about the output. All right, so right now we have this code going through printing out our string backwards. For next class, finish this function. Finish this function such that it converts the binary number we pass in, for instance this guy, and it should ultimately print out at the very end 26 in this example. Okay, we've already written the code to walk through the string one character at a time. And I'll even give you one last hint. You're probably going to need a variable. Maybe you call this guy place, and place is going to start off at 1. It'll start off at 1, then go to 2, then go to 4, then go to 8, so on and so forth. Make sense? Okay, so I'll put the assignment up just to give you a starting point. I'll just go ahead and give you this XML so you can paste it in and give you this as a starting point in it. Everybody know how to use the XML for this to generate the blocks? You just go over to the XML tag and just paste it in here. And then when you go back to blocks, it'll look like this. So that'll be a starting point. Okay? I will see everybody on, what's today, Wednesday? Friday. My week's all messed up because of when we started.